Hello, ladies and gentlemen. Advanced Algebra, Chapter 4.1, Graph Quadratic Functions in Standard Form. I am going to go through this lesson fairly quickly, so at any time you can pause it, rewind it, because I probably will be going too fast for you to copy stuff down as I'm going. So again, feel free to pause it, rewind it, just as long as you get all of the notes. All right, here we go. So, a quadratic function is a function that can be written in standard form. Y equals ax squared plus bx plus c, where a cannot be 0. The graph of a quadratic function is a parabola. First of all, the parent function. The parent function for this family is just f of x equals x squared, or you could just say y equals x squared. Remember, f of x is function notation, and it's the same thing as y. So what we want to do on this is we want to make a table. Okay, and we always want to start with a 0. X is 0, but I'm not going to do it at the top of the table. I'm going to do it right in the middle. So if I put 0 in there, 0 squared is 0. So I'm going to plot that dot. Okay, now I'm going to go 1. Okay, 1 squared is 1. So 1, 1. Plot that dot. Okay, I'm going to go positive 2. Well, 2 squared is 4. Plot that dot. Okay, I could go one more on that. On the positive side, I could go 3. 3 squared is 9. Okay, now I'm going to do some negatives. So negative 1 squared, and remember negative 1 squared, put it in parentheses, is 1. Negative 2 squared is positive 4. And negative 3 squared is positive 9. Okay, so remember the parabola kind of looks like a U. Draw your line through the dots, and that's what the parent function looks like. Now, a few things. This turning point right here in the center at 0, 0, that's several things. One, that's its y-intercept. And also, it's known as the vertex. So in this problem, it's both the vertex and the y-intercept. All right, let's continue. So in this case, we're going to graph y equals 1/2 x squared. And you'll notice I already graphed the parent function on the graph. So we're going to make a table. And again, I'm going to start with 0. So I'm going to plug 0 in there. Well, think about this. Half of 0 squared. Well, order of operations. 0 squared is 0. Half of 0 is 0. So this one's also going to start at 0, 0. Now, since we have the number 1/2 in front of x squared, we want to think of numbers that will not give us decimals. So I'm not going to use the number 1 for x. Okay, because think about it. 1 squared is 1, and half of 1 is going to be a decimal. So I'm going to do multiples of 2 because the denominator is a 2. So that means I'm going to now put a 2. So half of 2 squared. Again, order of operations. 2 squared is 4. So half of 4 is 2. So 2. Okay, now I'm going to go and plot that. So over 2 and up 2. 2, 2. Okay, now I'm not going to use 3. I'm going to use 4 because 4 is a multiple of 2. So half of 4 squared. Well, 4 squared is 16. Half of 16 is 8. So I'm going to graph 4, 8. All right, that's all that's going to fit on the positive side. So now we're going to do the negative side. So now remember, a parabola is symmetric. Okay? So if I have dots on one side of the parabola, I'm going to have a matching dot on the other side. So I'm going to do negative 2. Okay, well that's going to give me 2. Negative 2, 2. And I'm going to do negative 4. Negative 4 squared is 16. 16, half of 16 is 8. All right, I'm going to go ahead and draw my parabola. Now, I'm going to compare it with the parent. Let me erase this quick. All right, so I noticed that the vertex is the same, but I notice that the parabola is a little bit wider. Okay, but that's not the mathematical term I want to use. Okay? The mathematical term for that is vertical. Now, it's getting wider, it's getting fatter, so it's being pushed down. And being pushed down, that would be the word compression. So it's a vertical compression. All right. Moving on. The next one, we have a little bit more to it. Okay, in this problem, we've got negative 2x squared plus 4. So again, we're going to start with 0, and we're going to put 0 in there. So negative 2 times 0 squared plus 4. Okay, well, negative 2 times 0 squared, that would be 0, plus 4 would be 4. So 0, 4. Now in this case, I'm going to go ahead and use a 1. Because I don't have a fraction in this problem, so I'm not worried about decimals. So I'm going to do positive 1. Okay, so negative 2 times positive 1 squared plus 4. Okay, do the math. You should end up with 2. So plot it, 1, 2. Now remember, that one's going to have a partner. So negative 1 would then be with 2. All right, now I'm going to plug in 2, positive 2. So negative 2 times 2 squared plus 4. Okay, well, that gives me, this ends up being negative 8 plus 4. So that would be negative 4. So 2, negative 4, and negative 2, negative 4. Draw the parabola. And you will notice this one is not opening up the same way. It is actually opening down. And the vertex is also moved. So when we compare this one, Okay, now upside down, the mathematical term for that is reflection. So this is a reflection over the x-axis. That's one thing that it did. Okay, what else did it do? Well, it got skinnier. Okay, but that's not a mathematical term. That would be called a vertical stretch. Think of stretching a rubber band. It's going to stretch out. It's going to get thinner or skinnier. Okay? There's that example. Now, the next page, I'm going to read through the different things. And again, if you need to pause and copy them down. Here we go. So we're going to learn how to graph without using a whole table. So, graphing any quadratic function. This is a key concept, and you can find it on Moodle if you go to the textbook, page 237 in section 4.1. So these are the same as what's on that page. So characteristics of the graph of y equals ax squared plus bx plus c. First one, the graph opens up if a is greater than 0. So if a is positive, ladies and gentlemen, it's going to open up. The parabola will open up. If a is less than 0, meaning it's negative, then it's going to be upside down, or it opens down. Second bullet. The graph is narrower, skinnier, vertically stretched, than the parent if the absolute value of a is bigger than 1. Okay, so if that number in front of x squared, if the absolute value, remember absolute value means positive. If the absolute value of that number is bigger than 1, it's going to be narrower. It's going to be a vertical stretch. If the absolute value of that number is less than 1, okay, some fraction or decimal less than 1, it's going to be wider. That's the vertical compression. So just by knowing a little bit, you're able to kind of know what the graph's going to look like. Now, this next formula we're going to use quite often, and it should look a little bit familiar to you because it's part of the quadratic formula that we're going to get to later in this chapter. So, the axis of symmetry is x equals negative b over 2a. Okay, remember the song for the quadratic formula? It's in there. And the vertex of the coordinate is negative b over 2a. So we have the vertex, the turning point, and that will give us the x value for the vertex. The y-intercept is c. Whatever c is, whatever constant it is, that's the y-intercept. And remember, the x value for the y-intercept is always 0. All right, let's continue. Okay, so these steps, you can find them on page 238 in the textbook. Again, go to Moodle, go to the textbook, and you can find these. All right, so I'm going to go through each step, and then I'm going to, as I go, I'm going to graph it. So, step 1, identify the coefficients. That would be my a, which is positive 2, b, which is positive 6, and c, which is positive 3. Step 1 is done. Step 2, find the vertex. Well, to find the vertex, we have to use x equals negative b over 2a. So we're going to plug in the numbers. So x equals, now there's already a negative in front of the b, negative. Replace the b with 6 divided by 2 times 2. That gives us negative 6 over 4, which reduces to negative 3 over 2. So that's the x value of the vertex. Now we need, we're not done, because now we need the y value. Okay, so think about how we would find the y value of the vertex. Okay, we know what x is, so to find y, we're going to plug it into the equation. So we're going to replace the x with negative 3 over 2. So 2 times negative 3 over 2 squared plus 6 times negative 3 over 2 plus 3. Carefully type that into the calculator, and you will end up, believe it or not, with negative 3 over 2. Now, if you do not like the fractions, which in this case we probably don't, because we have to plot the vertex. So it would be easier to have it as a decimal. So I'm just going to convert each one to a decimal. And the decimal for that is negative 1.5. That's our vertex. So step 2, we found it. Now I'm going to plot it on the graph. Now, negative 1.5, negative 1.5. So the dot's going to be inside of a box. So left 1.5, down 1.5. So the vertex is going to be right there in that box. That's going to be the vertex. Okay, 1 dot down. We need a minimum of 3 dots for our parabola. All right, step number 3. Draw the axis of symmetry. Remember, the axis of symmetry is the line that cuts it in half. Well, the vertex is where the line of symmetry is. So we're going to draw a dashed line representing the axis of symmetry. That will be the middle of our parabola. All right? Step 3 is done. Step 4. Identify the y-intercept and draw its reflection over the axis of symmetry. Well, the y-intercept is the constant, 3. So, the y-intercept, sorry, my computer's being slow. The y-intercept is 0, 3. So let's plot that. 0, 3. There's my y-intercept. Now, remember, it's a parabola. It has a partner on the other side of the axis of symmetry. Its reflection on the other side. So this dot is 1.5 away from the axis of symmetry, so I'm going to go 1.5 the other way. That's its reflection point. Okay, that step is done. Now, step 5 is usually optional. Okay, optional. So evaluate the function for another value and plot it along with its reflection. Well, I think I'm going to try the x value of 1. Okay, I'm going to plug 1 in. And I'm going to see what I get. So that would be $11. Okay, well, that doesn't quite fit on my graph, but I'm going to plot it anyway. 111 would be like right here. And it also has a reflection on the other side, which would be right there. Okay, I'm going to draw my parabola through those dots. And there it is. So I graph the parabola. Again, you need a minimum of 3 dots. And then you can plot your parabola. And you need the vertex. You have to have that vertex. All right, well, let's continue. All right, so let's graph this one. Identify the coefficients. -1. B is 6. C is -8. Find the vertex. Okay, we have to use -b over 2a. And that's -6 over -3. Or -6 over -2. Which simplifies to 3. Okay, but now remember, I'm not done. I found the x value of the vertex. Now I need to find the y value of the vertex. So plug it in. Please make note the negative is already in front of the x squared, so do not put that negative inside. It needs to stay on the outside. All right, so this becomes -9 plus 18 minus 8. So we end up with +1. So the vertex is at 3, 1. Now I can graph that. Okay, so my vertex is at 3, 1. Step 2 is done. Step 3, draw the axis of symmetry. Okay, remember the axis of symmetry goes through the vertex. There it is, the axis of symmetry. Step 4, identify the y-intercept. Zero, -8. So I'm going to put that on my graph. Okay, that is my y-intercept. Check. Draw its reflection over the axis of symmetry. So this one is 3 away. So I'm going to go over here to 3 away. That's its reflection point. I do not believe I'm going to fit any more dots on it, so I'm not even going to attempt to plug in another number. Again, I need 3 dots, so I can now draw my parabola. It's upside down. There it is. And I do not need to do the last 2 steps. I did the last step, draw the parabola, but step 5 I could skip because there's no other number I could have come up with that would have fit on the graph. Again, you need a minimum of 3 dots to graph. All right, let's continue. Last one, we've got a minimum and maximum value. So the minimum value, if the parabola is opening up, the vertex is considered a minimum. Again, it opens up if A is positive. If A is positive, it's always going to have a minimum value. If A is negative, less than 0, it's going to have a maximum value. It's going to be upside down. Okay, so looking at this one, tell me, is it a minimum or maximum value? Well, it's A is a -2. So it's a maximum value. Then find the minimum or maximum value. Well, that would be the vertex. So to find the x value, we're going to use -b over 2a. So b, well, a is -2, b is 4. So x equals -4 over 2 times -2. So that's -4 over -4, which is 1. So the x value is 1. Now find the y value. So you got to plug it in. Y equals -2 times 1 squared plus 4 times 1 plus 3. That would be -2 plus 4 plus 3. I believe that would be 5. So the maximum for the ordered pair would be at 1, 5. And that's it. Okay, go back, rewind if you need to, watch it again. But that's how you can graph and find different parts of the graph by using this formula. All right, good luck.